rainy day in Ogden, Utah, but we're heading somewhere special.
You've arrived.
G'day trendsetters, today I'm coming to you from ENVE's world headquarters here in Ogden, Utah. Let's head inside. Also happening this weekend is the ENVE Rodeo event. Welcome to ENVE World Headquarters, and here is Jake.
Welcome, Gravel Cyclist, to ENVE.com. We're going to go on a little tour. So right here, this is the lobby. We are just getting ready for our builder open house. So on display here, we are starting to put up some of the 30+ custom hand-built bicycles that are all ENVE'd out in preparation for our open house tomorrow night and the inaugural rodeo event on Saturday. Going on our 5th year in this building. The building was, our first purpose-built composite manufacturing facility. It's right back based against the Ogden River Parkway, so it's right against a bike path and a trail system, which makes access to cycling, whether it be mountain bike, road, or gravel. There's sort of access from everywhere, and that's what we'll be debuting in the rodeo event. Is we'll leave right here from ENVE and we'll head out up the canyon on the bike path, and then we will hit some dirt. So that's going to be a fun event on Saturday. Well, from here we're going to head on out to production, and we'll give you guys a brief overview of how we do things here at ENVE. One of the secrets to composites manufacturing really is what starts in the machine shop. So behind every good composite part is an even better composite or even a better mold. And so all the molds are made right here in our machine shop. So it's a fairly large footprint in terms of what we do here at ENVE. So every mold, all of our fixtures, a lot of our tooling, a lot of our test lab fixtures are all machined and fabricated here. We'll walk straight back and kind of do a loop around the back here. Back here we have fabrication. We basically have 4 lathes that are going full time, just recycling the tools as they go through. So we get a certain number of turns as we make, a certain number of rims can go through every mold. From there, they're scrapped, recycled. Actually, the location just down the parking lot from us is an aluminum recycler. So we have a good relationship with them as we make our tools. In here is, you'll see, part of composite manufacturing is machining a lot of aluminum. So. It's pretty loud in here, so from here we'll move back into the warehouse, and then we'll go back through our raw material storage. Okay, so the next thing we're going to see is we're going to walk back into the warehouse where we store the rims that are getting ready for build, so finished goods. We can walk back there now. So as you can see, we have a pretty tall building back here. A lot of this was for this specific ability to store a lot of rims and inventory a lot of rims. This system here, as you'll see, is basically a first in, first out setup. So what happens is when a rim comes through finishing and it's gone through its final QC check and it's ready for assembly, it gets loaded from the back. So it'll get loaded onto the back here, and then you're always pulling the oldest rim off the front. So one of the crazy things, given the sort of current bike boom, every one of these rims has a customer tied to it. It's all just waiting to be assembled and built. So if anybody wants a job building wheels, come on out, we'll take you. So again, just finished goods storage. We're storing spokes, hubs, all the components we make are on the racking and the shelves behind us. These are all rims that are dispositioned for, they're called wheel kits. So it's a rim, spokes, hub, all pre-packaged for our distribution partners that do that assembly there. We have these discrete shipping lines for our direct-to-consumer business as well. So a lot of small parts and accessories shipped directly through here. So one of the cool features about the building and just the way everything's set up here is it's all about doing what's best for the product at the end of the day. So through this door we receive all of our raw materials. The raw carbon comes in off of a refrigerated truck, and it goes straight from that truck straight into this freezer. This ensures that we're not compromising the integrity of the resin systems that are used in the fibers. Carbon, we use a pre-preg material, so that means the carbon fiber already has the glue or the resin system impregnated into it. And just like glue, for example, if you leave it out in the heat, even at room temperature, if you leave it outside, especially on a hot loading dock, the carbon and the resin, specifically the resin, can age prematurely and go bad. So it's really important how you handle and care for the material. So A, because it's expensive, and B, because we really want to make sure that we're delivering the best quality product we can. Hey, being from Florida, you might find this a little uncomfortable, or you might love it. So this freezer's kept right around zero Fahrenheit, maybe a little up to that, 10?
Negative 10 to 0.
Negative 10 to 0. So we're actually waiting for some shipments of raw materials to come in, but in each of these pallets there's rolls of carbon fiber, and what is it, 100 pounds a roll?
80 to 100.
Sorry. With me too, let me introduce this guy. This is Clint Child. He's our
Hello.
Director of Engineering. He's going to have a lot of the answers to the questions about the technical aspects of the manufacturing as well. But would you say each roll of these is
80 to 100.
80 to 100 pounds of carbon? You can come stand closer to me. Now you're in the forefront, dude. Plus he wore his video shirt, his actor shirt.
So
Just so you know, folks, it is cold as
Now this is our cut and ply room. So when the fiber comes out of the freezer, so these are materials, raw materials, pre-preg. So the first thing that happens is the materials are loaded onto these racks, and then they're cut into panels. So those panels are eventually what become whatever part they're intended to be, whether it be a mountain bike rim or a road rim. Each one of these panels is cut, and I have a couple examples here of what we're talking about. So you can get carbon that's really, you can make the panel flexible this way, but it will be really torsionally stiff. So I can't, as I try to twist it, it won't twist very easily. And that's all about how you ply those panels together. This piece, on the other hand, is really stiff this way, but it's very pliable this way. And so this all has to do with the angles and the fibers that we're constructing. This is raw fiber. Basically the carbon comes in on some backing paper, and it's slightly tacky. And what you can see is it's all unidirectional. What we mean by unidirectional is it will just peel off like that. So it's all running in line. So the way we manufacture, the way you turn carbon fiber into a structure is you're basically taking those fibers and laying them up on top of each other. And so depending on what you want, whether you want it to be torsionally stiff, depending on what the flex profile is you need it to be, if you want it to be more impact resistant, you fine tune the angles of the fiber to accomplish the design and the product goals. So after the panels are cut, they each go into a vacuum table, which is what we have here. So in the vacuum table, we're basically putting the panels in and sucking all the air out of them to make sure there's no bubbles in our laminate. The ply operation is quite a few different tables and stations, and it requires quite a bit of hands-on labor to do that. After the panels have been made, they go onto one of these cutting machines, and the cutting machine is what we use to cut it into whatever shapes are needed to accomplish the layup schedule for the part. So basically after the part's been kit, this is what will eventually become a wheel. So you can see there's quite a few different parts, and each part has its own serial number. And so the way it works is we effectively take a kit that tells us this is for one of our 38 arrow clinchers, disc brake, and we know from the laminate this is all the pieces with the serial number and the quantity that have to go in. So that's just one step in terms of the QC process. After we have the kits built and put together, We come over here to where we start assembling the kits, and we weigh them to ensure that the weights are also in line with what they should be with the backing paper on them. Just as a little bit of a recap, raw materials in the freezer, raw materials out. Raw materials get rolled out and cut into panels. Panels get vacuumed and then cut into different shapes and strips, a lot of strips with wheels. Because we use continuous fibers around the entire circumference of the rim and really any carbon part we're trying to make. From there, once it's been cut and plied and kitted, there's QC check to make sure all the parts are present and accounted for. From there, they go to a secondary QC step where they're kitting into the specific wheel that they're going to become, and then weighed and signed off again by 2 different operators before we go to the next step, which is the layup. So back there, you see our layup operation, and that's where we can't go back too deep into just because it's a lot of proprietary stuff going on there. But basically every one of those, when we talk about machining a lot of aluminum, every one of those discs you see is a wheel mold. And those wheel molds are specific to a hole count and the depth, and because we have dissimilar depths front to rear with the road wheels, and then we have, of course, many different diameters of rim on both gravel and mountain from 27.5 up to 29-inch, and fat bike rims. It all sort of ends up being quite a bit of tooling to accomplish all the different wheel models we have. So wheels get laid up in the rims, and then they go back through the wall to what we call our bolt and cure, which is where the rims are actually pressurized and heated to be pushed into the shapes that ultimately become the rims. After the rim is laid up and loaded into the mold, the molds then come out here to what we call bolt and cure. So what's happening out here is the rim's preform is getting bolted up into a carrier that then goes into the oven. So manufacturing carbon is not too dissimilar from baking, for example. So you have a recipe you follow, all the ingredients in this case go into a mold. From there, those parts are put into an oven. And so in the case of carbon, it's about time, temperature, and pressure. So each one of these ovens has a PLC that is controlling, or a controller that's telling the recipe how long to cook for, what temperature, and at what pressure, and when to add those pressures to the rim. So depending on the model of rim, each thing is a little bit different. So each recipe is a little bit different. So the rims bake, and when they bake and they're done, they come out, they go under these chilling presses. The chilling press helps bring all that metal back down to a manageable temperature. In these cases, those molds are anywhere between 300 and 400 plus degrees, and so quite hot. So it's important to bring the pressure or the temperature down so that we can handle and cycle it all back through again. Once a rim has come out of the mold and it's gone through an initial QC check, or like, did it do a full cure cycle or not? Assuming it did a full cure cycle, it comes in here to finishing. So this room's our initial finishing room. So in this room, we drill the access holes for the rim. So all the spoke holes of the rim are actually molded into it during the molding process, which most people know about ENVE, is that we mold all the spoke holes into the rim. This is important because it leaves continuous fibers running around the circumference of the rim, and it makes for a more reliable wheel build. So these holes are drilled on the inside of the rim, and then what we're doing in here is we're removing all the flash. So this bit here is flash. There's some sharp edges around the rim. On the inside of the rim too, we're removing that, and we have a machine. As you've seen, there's not a whole lot that can be automated, but there are a couple things. So drilling the holes is obviously automated, and then some of the sanding is automated with this robot that we invested in a few years ago. So the robot picks up a rim, and it basically sands every surface of the rim that has a flash line on it. Okay, so this is the next area in terms of the process of rim manufacturing. And so basically, after the robot has had its way with each rim, it's sanded off all the flash, the spoke holes are drilled, the patches are in place. They come here for another QC check. So each rim has a final QC check. In here, we're looking for any minor defects that need to be sanded or buffed out. So here, each one of these rims is basically ready to be put into inventory. After it's checked in, it goes to wheel build. So we machine lace, and following machine lace they get dispositioned for retention and true. Once the rims are trued up and finished and brought up to tension, they get passed across the aisle to where they get decaled. So as he finishes the rim, he'll pass it over, and then it goes to decal, and then it goes into a box to be shipped to whoever it's going to. So as many of you know, ENVE has recently started making a lot more than just wheels and components. In April or March, we launched our new ENVE Custom Road, which is a 100% custom built road frame built right here out of this Ogden, Utah facility. So we're going to walk through it and you're going to see a couple bikes. This is our frame room. So in this room is where we actually assemble the bikes. So we've got 2 custom roads here. They're getting ready to be assembled and shipped to some lucky customers. And then back here you can see some of the jigs. We don't have any frames being assembled at this exact moment, but this is where the frames are bonded, the geometry set, the frames are bonded, overwrapped, and cured to eventually go into paint shop, which is where we're going to go next. So back up against the wall there you can see a handful of frames that are recently bonded and cured and waiting for paint. That's Shane. Shane's our talented master painter. He's the guy in charge of making all the bike's beautiful. So we're kind of running full gas in here these days. Between the custom builder show, so we're doing a little bit of contract works for some of our partner builders, as well as we have quite a collection of ENVE custom roads that are in different various processes of the paint. So here on the table we have the one-piece bar stem combos, again in various different stages of clear coat and primer. You can walk back here, a couple customer bikes getting ready to go out. So with the custom road, we have 4 different paint templates that people can choose from. So main design templates, and then within those templates, you can choose from 1, 2, or 3 of 40 different colors. That means there's lots of options for you when it comes to the paint. As everybody knows, the foundation to a really good paint job is a really good sand job. So making sure everything is super smooth. This is one of my custom road bikes. This is my race geometry bike. So this is the one that I go and suffer on the most. Mostly just at lunch. That's kind of where my road riding / racing has devolved into, is just the ever challenging ENVE lunch ride. So anybody's in town, you're welcome to join us. It's a good time. And then, yeah, those are all staff bikes. A lot of us, if you work at ENVE, you generally love to ride your bike. So quite a collection of bikes there. This one here, this is the steed of the infamous Neil Shirley. And he's got his little stormtrooper mojo there, which, I don't really know how it inspires him, but he sure seems to work for him. All right, everyone, so you've seen how the sausage is made, so to speak, to a certain degree. But this is where we do all of our testing. So very important to the product development process here at ENVE is the testing we do. We have entire ride testing protocols that we follow and a very healthy pool of test riders between our test rider pool and then of course our sponsored athletes and ambassadors. But this is where we actually put the product through the ringer in terms of machine tests. So we'll walk in here and I'll show you guys some of the testing we do. There's not a lot of tests going on at the exact moment, but in order for a wheel to be qualified for production or to go into production to be sold, a single wheel or single rim has to go through all the different tests. And so we test starting with a spoke fatigue or wheel build fatigue test, where we basically take a wheel and we lace it up and we take it up to way above the tensions that are prescribed, and we do it in a very extreme manner. So it's all the way up well beyond 50% to 100% beyond the recommended tension that the wheel should ever be built to, and then we bring it all the way back down to 0, and we try to unlace it unevenly each time. We have a process where we basically unlace it every 3rd or 4th spoke, going around the rim that way, so that you're really loading the wheel in a unfavorable manner. And so we do that 3 times. Then once we bring it up, on the 3rd time we bring it up to a final tension that is a proper spec tension. From there we use either one of these 2 Instron machines. more like usually this one here. It has a T-slot table that we can put different fixtures in, so we can test everything from handlebar, stems, frames, anything we make can be tested. This machine can push and pull, and it can tell us how stiff a rim is. So if we're just drawing baselines for data points on rim stiffness, this machine can do it, as well as vertical stiffness, or lateral stiffnesses, vertical stiffnesses can all be accomplished on this machine. So from the wheel build, it goes to this test, and basically what you see is with each test they get a little more extreme to where the final test is an impact test where the rim is actually broken. Given the world of disc brakes, we don't do a lot of rim brake testing anymore, but behind the curtain here is our basically one of our most important test fixtures, the one that probably took us the longest time to develop. But back here is a brake track test machine, so it doesn't get a lot of use these days as we're not doing rim brake development much anymore. It's used for sampling and batch testing from production, but that's kind of it because we're not actively developing new rim brake wheels anymore. Over here we have a wheel fatigue, so this is testing the fatigue of spoke holes, spokes, flanges, basically everything that rotates on the rim and is under tension. So just a general overall wheel fatigue machine there. And so once it's gone through and passed the fatigue, we go to impacts. These two towers here are impact test fixtures. This one here is the original, the shorter one. Due to the progression we've had with mountain wheels over the years and making them stronger, we actually had to build the new test fixture because this one, the rim strength was exceeding the abilities of the fixture to break them, and we didn't want to start over. I mean, we could simply add more weight to it, but then we're starting with a whole new sort of baseline of a test. So new test fixture to do impacts, and then the impact test eventually breaks the rim, and that's where it ends. So a single wheel has to go through that entire litany of tests, X number of samples to be approved for production. And so we're constantly using these machines to sample test the production. And so that's kind of the process for a wheel to go through the test lab. In addition, ENVE is now doing tires as well. And so we have a couple different machines that are specific to tires. This is a tool here that we use to test bead stiffness and measure diameters of tire beads. And up here we have a rolling resistance machine. This behemoth of a machine that we've built is a rolling resistance testing machine. So this is where we can test, obviously, the rolling efficiency of tire and rim combinations. A hub fatigue machine. So this is where we test the drive mechanisms on hubs. It's a pretty cool test. What's crazy with this test is our passing criteria is 10,000 cycles on this machine. And there's hubs that people are riding that haven't passed 10 cycles on this machine. So there's like a very large discrepancy in the world in terms of durability around drive mechanisms and hubs. But this machine will definitely test the ratchets or the pawls or whatever it is that are being used to drive the hub. So this machine's been very valuable over the years. This is a newer machine that tests fatigue. We don't have a test set up right now, but primarily we use it for testing handlebar fatigue. So basically handlebar or stems or whatever get mounted. This acts as your steer tube right here. The bars get mounted, and then this of course pushes and pulls in cycle or out of cycle tests to test fatigue on bars and stems. So because ENVE is now in the frame business, this was a very vital piece of equipment that we needed to develop specifically for testing. I mean, we use it for all of our handlebars and stems, but this, again, where we're making that one-piece bar stem combo here, this is the machine that was vital in ensuring the durability of that and the reliability and everything, but qualifying the laminate of that. And then over here we have a different fatigue machine. So we have a frame right now going through a fatigue test. This whole fixture can be configured to test basically every aspect of the frame. So right now it's doing a torsional test on where it's basically flexing the bottom bracket. The whole thing can be turned around and reconfigured where it's facing the opposite way, and then it can test the head tube. There's a different test for the seat mast. And I believe in total we have 4 and maybe 5 different tests that can be configured on this machine here. All right, everybody, so thanks for joining us on this tour of ENVE. We hope to see you at the Grodio.
So there you have it, a tour of ENVE headquarters here in Ogden, Utah. Thank you for tagging along, and if you haven't already, please consider subscribing to the Gravel Cyclist YouTube channel for content such as this, no bull bike reviews, content such as these bikes that will be featured in some future videos, product reviews, ride experience videos and other madness, as all of it is released to the channel. I'll see you in the next video.